Hello fellow nerds, welcome to our channel. In today's video we will talk about vectors. I learn a few concepts about vectors and how we can answer some of the questions about vectors. Alright, so we'll just begin by explaining what a vector is, right? So a vector is a physical quantity that has both direction and magnitude. All right, vector is a physical quantity that has both direction and magnitude. We talked about physical quantities in the previous videos. Physical quantity, something that you can actually measure. All right, now of the physical quantities, there's a type of physical quantity, a vector type and a scalar type, but in today's videos we're more focused on the vector type. However, the difference is a scalar only has magnitude. A scalar only has magnitude. All right, but we're not so much focused on scalars in today's video. All right, so vectors, that's about its definition. A vector is a physical quantity that has both direction and magnitude. Now magnitude is just a scalar value, right? With units, 4 meters, 4 centimeters, 4 kg. That's on the magnitude part, right? But then if that magnitude cannot attach direction to it, it then settles to be a scalar quantity. All right, so like the mass I had mentioned, 4 kg, you cannot add direction to 4 kg, which means you cannot add direction to mass, and so mass will stick to being a scalar quantity. All right, speed on the other hand is 4 meters per second, 5 meters per second. This is speed, right? But if you can add direction to speed, this is speed, which is a scalar quantity, but if you can add direction to speed, it becomes velocity. Due north, this becomes velocity. Because of the direction added to the magnitude, the velocity will then become a vector quantity. That is why velocity is a vector quantity, speed is a scalar quantity, because velocity has both magnitude and direction. All right, so having talked about what a vector is and differentiate it from a scalar, which is on the other section of physical quantities, we will talk about how we can find the vectors, how we can find vectors. All right, okay, so vectors is so as a vector, so a vector in its own in its own makeup can have projections depending on in what graphical environment it has been placed. So if you place a vector in this is your x-axis, right? Coordinate geometry, right? This is your two-dimensional kind of graphical arrangement. All right, so if you place a vector in this type of arrangement, so we say this is going to be vector v. Vector v will project a part of it in the x-axis and a part of it in the y-axis. These components, these projections of the ultimate resultant vector are what we call components of the vector. So the part that is projected in the x-axis will be the x component of the vector in question. The part that is projected in the y-axis will be the y component of the vector in question. All right. Now, how do we find these components? They follow a triangular, we would say a triangle method kind of issue, right? Using the simple SOHCAHTOA arrangement, SOHCAHTOA, right? All right, where you have that angle, right? So when we have these components, I mean the velocity, these are only showing much of the magnitude, right? But we've said vector should have direction. The angle in question signifies the direction in which this vector has been aligned, and so the angle is also very important to find the direction of a vector. All right, so magnitude, those components to find the resultant vector. Okay, then the angle is for the direction. All right, okay, so SOHCAHTOA will help us derive formulas to find these components. Okay, so wherever the angle is facing is called your opposite, right? Okay, the slant aspect is called your hypotenuse. All right, the remaining aspect is called your adjacent. All right, so from SOHCAHTOA you have sine theta is equal to opposite over hypotenuse. So sine theta is equal to opposite. Opposite is this item that is a projection in what axis? In the y-axis. So this will be your vector component in your y-axis. All right, the hypotenuse is your resultant velocity, so that will be your resultant velocity. You can put an r there. Okay, adjust v to still be fine. So the vector component y is equal to v sine theta. So this is going to be the vector component of y, and this is a formula you are going to use. All right, so okay, so this is the vector component in y and the formula we're going to use. Okay, let's look at the vector component of x. So we have the car there, that is cos theta is equal to adjacent over the hypotenuse, right? Okay, cos theta is equal to, what is your adjacent? The adjacent is the part that is projecting in the x-axis. So vx, vector component of x over the hypotenuse, which is your resultant velocity. All right, you cross multiply, you'll have the vector component of x will be v cos theta. All right, this is going to be the formula we will use to find the component of the x component of the vector. All right, okay, so we have one other aspect. We'll have tan theta is equal to, that's TOA, right? Opposite over adjacent. So tan theta is equal to, what is the opposite? The opposite was over vector component y over adjacent vector component x. So this is going to be, but again, what are we finding here? We are trying to find the direction, right? Because we have to make something the subject of the formula. So this can also be written as theta is going to be tan shift, is it? So shift tan, tan shift will give you, come and show this when we solve how you can do that mathematically using a calculator. All right, this will give you the angle, which we've talked about, saying the angle will denote what? The direction. All right, okay, so these are the components and the direction. Okay, what else are we supposed to look at? We are going to look at vector. All right, so in an attempt to add vector, so vector addition, or rather vector subtraction. All right, vector addition, vector subtraction follows a certain rule, which is you add. Now there's two methods you can use to add vectors, right? You can graphically add them, or you can arithmetically add them, or algebraically add them. However, the vectors themselves do not entirely follow the typical algebra addition, where you have 4 plus 4 to give you 8, and sometimes they don't entirely follow this kind of way. That is why the graphical method is more appropriate. All right, but even this one works, but well, sometimes not as much. The one we'll look into that a bit later, but in today's video we'll try to focus on the graphical aspect because it is more convenient. Okay, so the graphical method follows a certain rule, which is head to tail rule. The head to tail rule states that you have to add vectors, or you should add vectors head to tail. What do I mean? So if you have a vector A, let's say you have vector A plus vector B, right? If you're trying to add vector A. In fact, so if this is how it's written, so we are saying vector A plus B, we are saying we're adding plus B. The B is being added to the A, right? So if you have a vector A in that direction, we have to show it by an arrow because these are vectors, all right? So if you have vector A like that, and you want to add vector B to vector A, you have to add vector B using this kind of rule, this rule. So the head of A, like head is the first aspect, right? So head to tail. So the head should be added to a tail of the vector that you're adding. So vector A has got head, right? Head to what? To tail of what? Of B, which is a vector you are adding. So the head of the vector in question should be added to the tail of the vector that you are adding. The vector we're adding is B, right? The vector in question is A. The vector in question A has a head. That head should be added to the tail of the vector that we're adding, which is vector B. Head to tail. Head to tail. That is basically how you add vectors in graphical method. But again, we'll look at it. It will probably sink more when we look at a few examples. All right, so let's try to look at a few examples, and more concept will probably unfold in those examples. Okay, so let's begin with the first example that we have. Vector A has a magnitude 8 units and makes an angle of 45 degrees with the positive x-axis. Vector B also has a magnitude of 8 units and is directed along the negative axis using graphical methods. Find A plus B. All right, what do we have in the question? So vector A and vector B. Magnitudes 8 units, they both have 8 units, all right? Vector A has an angle 45 degrees. Vector B is directed along the negative x-axis, all right? So let's do this. Okay, vectors are very simple, okay, have to take it easy. All right, graphically we are saying you draw your graph first. This is your x-axis, right? This is your y-axis. Okay, we have two vectors. Vector A, 8 units, 45 degrees. That's above the x-axis, above the positive x-axis, right? B, 8 units. This was along the negative x-axis. All right. Okay, we'll first write. Okay, so we have this is your negative aspect, this is your positive aspect, right? This is your negative, this is your positive. Okay, 8 unit, 45 degrees above the positive x-axis. All right. Okay, so where is your positive axis? This is your x-axis, right? Where is your positive? The positive is on this end, right? So all vectors are coming from a single origin point, which is there. All right, so 45 degrees above the positive x-axis. So we are moving 45 degrees from this positive x-axis line, right? So above this 45 degrees, right? Okay. Oh, basically this forms a 90 degrees, right? So half of it should be 45. So your vector is in that direction. This 8 units, and this angle is 45 degrees above the x-axis. All right, above the x-axis, 8 units magnitude. All right. What else? B is along the negative x-axis. Where is your negative x-axis? This side. Along just means right through, more like parallel. Right through it. Right through it is vector B with an arrow on top. Okay, from the origin right through it. So you have a vector in this direction, and you have a vector in that direction. Sorry for the scruffiness in that one. Okay, all right, so what is the question? Find A plus b. All right. So what have we said? We've said addition of vectors graphically follows one rule. What rule is that? Head to tail. All right. So what is the vector in question? What is the first vector, and what vector are we adding to the vector in question? A plus b signifies b is being added to a, right? A is already there, plus what? Plus what? Plus, you need to add something, right? So, A, add what? Add B. So that is A plus B. And that's exactly what we want to do graphically. All right, so how do we do that? So again, we'll draw the line like that. This is your y, this is your x, right? We know A was 45 degrees. This is your A, right? Okay, now these vectors should be taken as individual vectors coming from an individual origin. Specifically, they are coming from the same origin, which is 0. But if you are supposed to specify it as an individual vector, it should seem as though it is the only vector coming from that origin, that very origin. All right, so vector A is coming from origin 0, right? From there, moving 45 degrees, positive x-axis, 8 units, right? Vector B is 8 units along the negative x-axis. Now, if you are going to add vector B to vector A, you are going to assume at now head to tail. This is the head of A. The tail of B should be right here, which means B should originally start from here. So we are going to draw another graph of sort right there. This will be B's origin. Exactly. Okay, so B's origin, from there, then we can move the vector B. All right, so vector B from there is along the negative axis, which is going to move like this. This is going to be your B. Does that make sense? So you'll have, so literally you have one that looks like y. This is x. You have 45 degrees for A, and you have B moving in that direction. Okay, this is basically how it is. All right, and for you to find now, A plus B should provide you a result, right? This result, the sum, is what we're calling the resultant velocity, or the resultant vector in this question. We're not very specific on what type of vector we're dealing with. All right, so the resultant vector is drawn from the tail of the first vector to the head of the last vector. We only have two vectors in here, and so the tail of the first vector, which is vector A, to the head of the last vector, which is vector B. So this is going to be your resultant vector. And our question needed us to find the resultant vector, but graphically showing it. And this is how you graphically show that you have added A, you add an arrow, tail there, and it's resultant. So A plus B resulting into that. And that is basically graphically showing that you've added two separate vectors, A plus B, using graphical method. That is how we've shown that we've added vector A to vector B. We've shown the resultant, and we showed how graphically A and B are adding, how B is being added to A using the rule head to tail. A minus B. All right, now how is A minus B going to be like? All right, now this one was A plus B. This is A plus B, right? Vector A plus vector B. This is how you graphically show it. All right, but it should be more straight. I mean, when you have a ruler, you have an actual graph, you can do the scale 8 units, so the lines can actually come out more straight. But basically, this is a concept around it. All right, so A plus B. The next question is A minus B. Now, Minus is a subtraction. So this is subtraction of vectors. How do we subtract vectors? All right. Basically, subtraction of vectors is like the opposite of the addition, right? So this basically would have been written as vector A plus negative B plus negative vector B. Now, negative vector B only means that it is in an opposite direction. It is in an opposite direction. So the opposite direction of vector B, if vector B is in this direction, so if vector B is in this direction, vector B itself goes in the opposite direction, will be denoted with a negative sign in front. All right. So vector B is equal in magnitude with vector negative B, except it is in a different direction, or rather in the opposite direction. All right. So vector, so okay, we have the x-axis. The initial graph was, this was our A, right? This was our vector A, and our vector B was in this direction, right? This was our vector B, right? But since we are in this, A minus B only means you are adding A with a negative B, like we've shown it there, right? A plus brackets negative B, which means if you are adding negative B to A, all right? Just like we added B to A in the first example. So in this case, we are trying to add negative B to A. Now, the question is, what is negative B? Again, negative B is said to be the opposite in direction to B itself. Now, B was in this direction, right? B was in this direction. So negative B should be exactly same magnitude, different direction from B itself. So from this same point, negative B is moving in this direction. This is the opposite direction from B itself. This is going to be negative B. Opposite direction, 8 units, but different direction. And so this is going to be negative B in the opposite direction. All right. So if we're adding negative B to A, this is how we arrange negative B to A, head to tail. And its resultant will be from the tail of the first vector to the head of the last vector. So resultant for this one will be this side. So we can arrange it in a more clear version, where you have, this is X, this is Y. So you have, this was your A, 45 degrees, right? Your B will be in that, it will be a negative B. Okay, the resultant will then be that. And this is going to be graphically showing A minus B. This is how we show this graphically. All right. Okay, in today's video, we will end here. We've talked about what a vector is, how we can denote a vector using an arrow on top, board, and an arrow on top, then the head to tail rule on the graph, which is more convenient. Basically that. All right, so in the next video we will look at some of the examples, so the concept can actually stick a bit longer for like that. All right, so in this video I think we'll end here. I hope we've learned something, but don't you worry, in the next video we'll look at more examples, and I'm sure the understanding will be probably more. All right, laters then. Peace out.